sequence with a common ratio, and you could write multiply. So it's a sequence with a common ratio, and you can write multiply. And what do you think R is? R is the common ratio. So now I'm going to ask you, what is R instead of what is D? So if I'm talking about R, it's geometric. If I'm talking about D, it's arithmetic. The closed and recursive formulas work exactly the same way as they did with arithmetic. A sub n, what are you starting with and what are you multiplying by? But your n minus 1 goes up here in the exponent because you're multiplying, let's say, by 2. When you multiply by 2 again, that's like 2 squared. When you multiply by 2 again, that's like 2 cubed. So these act just like exponential functions. So you could write over here that they're most like exponential functions. What were arithmetic most like? Linear. So arithmetic saying linear and geometric saying exponential. So when I asked you to compare and contrast arithmetic and linear, one has a common difference versus one has a common ratio. One is like a linear function and the other is like an exponential function. Recursive is a little bit harder, not as useful, but so you say, how do you get a sub k? You take the term that comes before it, so we call that a sub k minus 1, and you multiply by the common ratio. And you have to tell the person the starting value for a sub 1. So a sub k equals a sub k minus 1 times r, just like up here, times r. And then you have to say where to start, like on this one I'm starting at 3. A sub 1 equals 3. So because we've done so much work with arithmetic, I think that this will be pretty easy for you. But can anyone tell me what's the common ratio in this example? Yeah, it's just multiplying by 2 every time. So if I was going to write it as a closed formula, where am I starting? I'm starting at 4. So I write 4 times 2 raised to the n minus 1 power. So that's it. Can someone tell, like Corbin and Parker who haven't been here, why is the closed formula easier to use than recursive? Why do I want a closed formula? Oh, do you know the answer, Corbin? Because you could just plug in 100 for n if you wanted to. On recursive, you have to find terms 1 through 99 to get to term 100. So recursive is not as useful. A sub k equals a sub k minus 1 times 2. And I have to tell the reader to start at 4 as the first term. So I'd have to write out that whole thing. A sub k equals a sub k minus 1 times 2, a sub 1 equals 4. And then I just do times 2 is 8, times 2 is 16, times 2 is 32. So this says, let's just find the common ratio and find the closed formula and use it to find a sub 6. What am I multiplying by on example 2? Just times 3 every time. So my common ratio is 3. I'm going to write R equals 3. So what's the closed formula? A sub n equals 12 times 3 to the n minus 1 power. So now I'd like you might need a calculator. So what is a sub 6? I actually tried to collect them and charge them. Oh, yeah, they're not fully charged though. Oh, wow. I gave you guys 2. Can you share that stuff? Everyone know how to type it in with the exponent? So what is a sub 6? Using your own. A sub 6. You have your own here? I think I have somewhere in one of these bags, but I don't know where it is. Does everybody have something? Oh, you need one? 12 times 3 to the 5th, right? Because 6 minus 1. 12 times 3 to the 5th gives me 29/16. Sound right? Anyone need help typing that in? All right, what's the pattern on number 3? How do we go from negative 1/3 to 1/9 to negative 1/27 to 1/81? What would I have to multiply? Huh? And not even -3, it's actually negative 1/3 because it's the denominator that's getting multiplied by negative 1/3. So this is one of the times when your starting value and your ratio are the same. So we'll do it the way that we've been doing it. Negative 1/3 times negative 1/3 to the n minus 1 power. I don't think it matters if this guy is in a parenthesis or not, but this one needs to be in parentheses because this is going to change sign from negative to positive, negative to positive. The shortcut would be a sub n equals negative 1/3 to the n, because this is just negative 1/3 to the first power. This is negative 1/3 squared. This is negative 1/3 to the third power. But if you're more comfortable with just the same closed formula every time, feel free to do that. I only have to go to a sub 6. If you type this into a calculator, you're going to get a nasty decimal. So let's just write out the next term would be negative 1 over what? All I have to do is multiply the denominator times 3, right? So 81 times 3 is 243. So I went negative, positive, negative, positive, negative. So my next term, term 6, is going to be positive. And all I have to do is take 243 and multiply by 3 again. So to me, it's nicer to write it as 1 over 729. If you type the formula in, you'll get, the decimal 0.00137. 0.00137. So if you typed it in and got that, you got the same answer. But I think when it's a fraction, it's kind of nice to be able to see the pattern and see that that fits in order. Okay, a couple more examples, then you're going to try some on your own. So now this one says the third term is 4, the fifth term is 1. Find the closed formula. So I have the third term is 4, and the fifth term is 1. I have to be able to multiply by something and then multiply by something and get to 1. Can anyone think what that would be in their head? It is 1/2, because 4 times 1/2 would give you 2, right? And 2 times 1/2 would give you 1. So the R value is 1/2. What if you couldn't figure that out in your head? So if you're going from 4 to something, 4 times R squared is what's giving you 1, right? Because you're starting at 4 and you're multiplying by R and by R again. So you could set this up for yourself, divide by 4, and take the square root of both sides, and that would also give you 1/2. So just take the square root of 1/4 on your calculator and just prove to yourself that, oh, okay, R would be 1/2. So if you're not a guess and check kind of person, you need a formula. If 4 times R squared is 1, R is 1/2. Some of you could just see it. So you're going to have to find a sub 6 and find the closed formula. So a sub 6 is easy, right? Because of that 4 to 1, what's a sub 6? Just 1/2. So a sub 6 is just 1/2 because we could just multiply by 1/2 again. What would I get for a sub 1? That sounds right, because 4 times 2 would be 8, 8 times 2 would be 16. So a sub n equals 16 and then times 1/2, because that's my R value. And make sure this is an exponent, so this should be a superscript. For arithmetic, it's sitting down here, regular form. So I'm going to be a little bit picky, just like I was with logs. Logs were supposed to be like a subscript for the base. This is a superscript. All right, here's one last one. Given this sequence, determine whether 3,645 is a term in the sequence. And if it is a term, what term is it? I want to give you a minute to try that one on your own. Either plug something into your y equals menu, guess and check. You could continue the pattern out for, 10 terms and see if you get somewhere. See if you can, I'll show you a couple methods in a minute, but see if you can figure it out with some critical thinking this morning. And I'm just going to peek ahead to 504. Wait, no, 507. Yeah, we'll do 507 and then some quiz review. Now I'll probably call it the day. These calculators typing in is a little harder. Do you know how to do this problem in this calculator? Because you need the extra, let's see. So did people figure it out? Did you just do the pattern? I guess you figured out what term it was. Like, is it term 3 or term 8 or term 10? How'd you do yours? Oh, you just guessed and checked? Oh, okay. So you basically the same as kind of finding all the terms, right? So you did that and you found all the terms. Okay, that's fine. You can find all the terms by hand. That's a good strategy. So if you just continue the pattern, I used the calculator to give me the pattern because I didn't want to type in times 3 times 3. So I just put in my y equals menu the function, which would be, it's kind of too dark on my calculator screen here, but yeah, you can't see it, of course. 5 times 3 to the n minus 1 power. And then I went to my table and it gives me all the values and I can see where 3645 shows up. You could also write 5 times 3 to the n minus 1 power equals 3645. So your first step could be taking this number and dividing it by 5 to start with, because 3645 divided by 5 is 729. So then you're looking for 3 to what power gives me 729, right? And then whatever this is, you can backtrack and figure out what n would have to be. 3 raised to the 6th power is 729. I can't see on this calculator, but if x has to be 6, n would have to be 7. So 7 minus 1 would give me 6. So yes, it would be term 7, right? Or did you guys get term 6? Wait, in my table, is it term 7? It's term 7, right? Because term 1 was 5. 1, 2, 3, 4, 5, 6, 7. Term 7. So anyway, that's geometric. So I'd like you to take, I don't know, maybe 20 minutes. I will put a practice kind of quiz on the board in about 20 minutes. But I'd like you to try numbers 1 through 7 on page 507. And there's 2 application problems on the back. So you're going to try thinking about depreciation just like exponential functions. We've done this before with exponential functions. You already took a test on exponential. So take a little bit of time and try that guided practice 507, and I will come around and give you some assistance if you need it. So in case you want to go back and do this later for practice, I showed you how to get the common ratio, but it would be 20.25 after you multiply by 1.5 and by 1.5. Noah brought up a good point. He found a different pattern. He said, well, all I did was I added 2 and then I added 3. So then he added 4 and added 5. But the directions say it has to be geometric. So if it just tells you to find a pattern, find whatever pattern you want. But if it says geometric or arithmetic, it has to be like the adding, subtracting, or multiplying. I wanted to point something out. On number 2, I think everyone's paper that I checked multiplied by the ratio of 1/2. It's going to be wrong if you write divided by 2, because the definition of geometric is it's multiplying by a common ratio, not dividing by a number. So I know that I accept addition or subtraction kind of as the same thing, but you're multiplying by a common ratio, so you want to multiply by 1/2. I think everyone did that. And if you notice, they use find the closed formula interchangeably with find the nth term. See how I wrote closed formula in parentheses? And down below, I just wrote find the nth term. So you've got to accept in your brain that that just means find the closed formula. On number 3, did anyone have trouble finding the R value? Because if you couldn't figure it out in your head, you could say that 64 times R squared equals 1024. Divide by 64 on both sides and take the square root. You'll get 4 is your R value without having to guess and check. This one, they gave you all the information and you just had to write it as a formula. So you got to have to memorize that formula. And the last one was when you plug in, what do you have to plug in? The 15th term, 39.6. You want to use the closed formula. I wanted to talk about the back page together because we're going to be doing some applications this week. And they go directly with exponential. So Parker, I would do these 2 problems with us maybe, Parker. Because these are dealing with exponential, the same as what you're taking your test on. Oh, yes. Thank you for letting me know. I'll put in a smart pass. I'll give you kind of a quiz. Let's pretend we're taking our sequence quiz. Because I know it's been a while.